Hi, I'm Mario. I also do like Kubernetes stuff for the Kubernetes project. So I'm the tech lead for comms. So I'm also the person that was responsible that got the Kubernetes IO Twitter account suspended for a week. Because fun story there, there's an age limitation. So when you are below 13, you're not allowed to have a Twitter account. And we thought that we enter the birth date of the Kubernetes into the Twitter account, and then suddenly it was below 13, it was only 10, and got immediately suspended. And so we lost an account with 350,000 followers, and this was made possible by, hey, let's put in the birth date of Kubernetes inside of the Kubernetes Twitter account so that we get the balloons. If you have something like this, don't do it. It's a bad idea. So we want to talk about security. Who is in the security department here? 1, 2, 3. I'm sorry. I'm really sorry. Who is working in ops? Who is a developer? Who is titled DevOps? I feel bad for you. All right, so old world. We talk a lot with enterprise customers. Enterprise customers are funny people because they have also like big teams, and big teams usually don't talk to each other because, I don't know, maybe they don't like each other. And there's usually a security team, and you also need to talk to the security team, and you also need to talk early to the security team, because there's 3 different concepts that are in a security team in the old world, because I have my firewall, and my firewall is the best thing that I have as a tool in my security world. So I build a parametric defense around everything, so I'm secure. And then everything is fine. And when something happens, we have a manual process that someone looks into this, and someone also, oh, you want to have a new connection to something? Yeah, please open a ticket, and we will talk to you in 3.5 weeks because we don't have capacity. Also, our security team is our security team. We will never ever talk to any other department because they are bad. They want to bring bad things into our company. So let's start with security, parameter security. As you see, parameter security works fine because there's no way around it, no possible way. So what is the most common attack vector on a company nowadays? Any idea? Exactly. The infamous layer 8. The main problem of everything. The human that is sitting in front of the PC. And we have the real problem that we have like a lot of attack vectors in a company. We have departments that have no clue about IT because it's not their job, right? They are there for other, but they use IT equipment and IT software, and they get emails and they click on things in emails because you click on things on emails because it's a link. Obviously, you need to click on it. So the problem is that we have another layer of attack that we need to secure. So our parameter security has a problem because we go around our parameter security. So we have a multi-layer threat level. And the multi-layer threat level starts with the human layer, and we will see a pattern in this, that it's repeating and that it's kind of going in a recurrence situation. For example, who is doing meetups in the office? Meetups. You order pizza usually, right, on those meetups? And when are those meetups usually happening? In the evening. So some person comes with pizza boxes in your office. Who is checking them? Are they escorted all the time? Can they move around? This is also a problem. So this is an attack vector on your company. Every meetup that you do, you should not stop meetups. You should just keep in mind that this is also an attack vector. And then we have also the parameter security. We have key cards, we have PIN codes, we have access management, but something happened a couple of years ago on a parking lot of the CIA headquarters. there was a USB stick lying around. And what do you do when you find an USB stick in front of your headquarters? You pick it up, go inside of your company or in the CIA and plug it into your system so that you can see what's on the USB stick. That's also an attack vector. And then we have the problem because then we are already inside. Then we are already inside of the system. Then we have also the problem with network security. We have unhappy employees that want to leave the company and want to take some information with them. So they have access to a couple of stuff that they might want to take with them and that they should maybe not see. So we need also to build a layer inside of our company that's securing this. Also, we have the problem, we buy a lot of software, like we get the software from there, software from there. Are we sure that the software that we buy is secure or don't have like using an outdated project where something is inside of this? That's another attack vector. So we also need to keep care. Of course, if we figure out that it was the software that we bought, we can get some money back, but the damage is already done. And that's going every step, every deeper, even more in a deep stack, so that we get the problem. And usually, it's always the human that is doing the error. So this is something that we need to, I don't want to say eliminate, but yeah. And the next topic that we had is manual processes. The manual processes are great because if something happens, then I can deal with it. It's not, we don't need to deal before the security breach happened. We do need to do it afterwards. So it's an ad hoc thing that is happening, and there's no prevention to foresee this or to block this. Who is familiar with CVEs? If someone is not raising their hand, CVEs. That's good. So this is the current amount of CVEs that we have. A CVE is a common vulnerability exposure. And you see this gap between May and now. And I actually looked it up like 10 minutes before this talk. So you can go to cve.org and check this out. And this is a problem because you need to keep up with this number, because this could potentially affect you. And the problem is that this is growing. This is growing fast. When we look at this graph, this is the amount of CVEs that has been filled over the last years. Good luck keeping up with this, because every single CVE could potentially affect you, or maybe not. And to make this even more funny, something happened in May. So kernel.org, anyone knows what kernel.org is? Kernel.org is basically the organization that is taking care of the Linux kernel and or the conglomeration of Linux kernel development, and they were now a numbering authority. And what they did is they created a bunch of CVEs of issues that already have been fixed. And what they did is not, let's be smart and took only real vulnerabilities. No. Everything that was flagged a bug is now a CVE that was fixed. Good luck keeping up with this number, because this is now making the growth of the CVEs exponentially large. So you can't even now rely on CVEs anymore. Yay. And the last part that we had is our silo approach. Our silo approach is, I don't need to talk to other teams because other teams are bad. And eventually we came up with this cool new technology 10, 15, 12 years ago, no more, 14 years ago, which is called containers. Because if we have a shitty application, we just put it into a container, and then all my problems are gone because it's in a container and I can ship the developer machine. That's great. And so our solution was put bad stuff into containers so that we can basically move them around, and we don't need to take care of it because it's running inside of a container and I can trust everything. So I know this is old. Containers were, we moved from pets to cattle. Because when I started in 2004, our database servers had a name. It was called Loki. It was called, and it was the best server that we had, and we always needed to care about the server. But now we moved eventually to DB0, so it's no longer this pets and cat. It's no longer this pets approach. It's this kettle approach. So we can basically move on into an anonymized thing, and keep this in mind because this will become more important later. In the old world, we have to get now to what we should now do instead of what we did before. We had ports, or we still have ports, but in the past, ports were like the interesting thing to make everything secure, because if I block a port, everything is fine. So everyone knows that if I use port 80, I have HTTP. That's a given. So there's no other option. Or if I use port 25, it's SMTP. And I could always rely on that my application is running on port A, port B, or port C. And the funny thing is that everyone was relying on this. So we basically, we have a stateful firewall set that says, this port can only do this. In the theory, that's fine. But in the cloud-native world, when we go into containers, ports are not a static thing anymore, because ports are changing, ports are moving, ports is not the thing to rely on. And the problem is that if in the old world, I know that this port is this, so I can basically manage this because it's static. So in the new world, that's not the case anymore. We have ephemeral reports that basically say, my web server doesn't need to run on 80. Inside of my cluster, because that's not the point. We need to basically go away and say, like, I rely on a port security only. What we need to do is we need to implement a zero trust environment for our world. We also need to have an encryption layer that all of the traffic that we have, even inside of our environment, is encrypted. The good thing is, in Kubernetes, this is luckily now possible with things like Cilium, where you can just encrypt your whole internal traffic. And what we also need to do is that it does not matter if a port is open between applications. The important thing is who can talk with whom. So which application is allowed to talk with which other application. So then the port doesn't matter anymore, because they identify or they basically talk to each other, and only they can talk to each other. So I can basically also see issues inside of the traffic that is happening, that is not inside, that is happening on the port. So I can basically have a threat detection of things that happen inside of this. So our main approach is we want to have a fine granular identity and access management. So only things can talk to each other that know it. We have also the idea that networks are not this big thing where we say like, hey, /12, good luck, and have fun with this. So it's a granular segmentation of networks, so that we have small networks where they are only as large as they need to be, so that we can basically also have a network separation layer. We also need to have like a behavior analysis, so that it's not the important thing to how is it happening. The important thing is what is happening inside of my network, so I can see where is traffic that is not behaving in a pattern how it should behave. Also, the next point would be API gateways, so that we have a common point where we can control who is talking to whom, and where we have our own security mechanisms that can basically select who is allowed to talk to each other. So we are still in a world that has ports, but they are not the most effective way to have our security present. The idea behind this is DevOps, and you all know DevOps, and whoever says that DevOps is a role, no, it's not a role, because DevOps is a concept of a working method. It's the name for a team. It's not one person cannot be a DevOps engineer, because if one person is a DevOps engineer, he would write the application, he would be responsible for deploying it, he would be, the person also would be responsible for monitoring it, and whoever has this concept, then yeah, good luck, because not a single person can do this. And that's the main misconception that we have, that DevOps is a role that we call, that people call DevOps a role. It's about sharing responsibility. So, back in 2022, there was an article on the Newsstack.io that we heard that single services became cattle. And now we are moving into the world where clusters are becoming cattle. Who of you is running more than 3 Kubernetes clusters? More than 5? More than 100? You will get there. So the idea is that we have a lot of, the adoption rate and the amount of clusters will be ever growing. So the problem is, this is not manageable manually. So we need to have an automation. We need to automate all of the process in our development world. So we basically need to have a development pipeline. Our infrastructure needs to become immutable, so that we basically have the point that everything that is in our infrastructure is inside of a repository, that we only can change it if we make a pull request, if we have a review by at least another person, so that there's no one is going on, oh, it's Friday evening before Christmas, let's go on our main database server and do the update, and then leave the company for vacation. So that's basically our goal, and we need to have observability throughout our infrastructure. So there needs to be a visibility layer at all of the time that looks like what strange things are happening, or hopefully not, in our cluster. And the problem the goal to achieve this is relatively easy, and now people will argue that's not a solution because we can't do it. It's shift left. Because shift left puts a burden on people that don't want this burden. Because shift left means that our security moves out of a security team into development, into our development team, into our application teams. So we need a couple of tools for this. Who uses SAST and DAST tools? That's more people than I thought. I'm so happy. That's really great. So SAST is basically structural testing that identifies weaknesses in our application. DAST is dynamical testing, which basically tests while the application is running. So you can basically call it black and white testing. So once you can look into the code, and the other thing you can't look into the code. And then we of course need container scans. So who is using container images from Docker Hub? Oh, bad. Do you look at those manifests? Do you look at the updates there and make sure that they are up to date? I hope so. But how many containers do you have? This is probably a hard manual process, a hard process if you would do this manually. So what we need to do is we need to scan containers in an automated way that we can rely on, hey, let's use only container images that are up to date, where all of the dependencies are up to date. And we also need compliance scans, because luckily we are living in Europe and we have some regulations, only a little bit regulations. So anything that is basically running inside your company also needs to be GDPR compliant and stuff like this. So maybe compliance scans make also sense, because you might have software that violates GDPR. And that's also a problem. And of course, as we said, dependency scans. This one package that we have in our application that is maintained from one person in South Korea that is working on this like every 6 months might be a security risk. So what we need to move on is we need to go into a direction of zero trust architecture, so that we don't trust anyone in our architecture. So we basically say no one can talk to anyone. that we basically reduce everything to the minimum of connection points and then open it up for what it's needed. We also say that everything that we do in our design needs to be verified. And microsegmentation, that when we have an incident, the blast radius is small. Okay, people are now moving again back to monoliths because there was now a new paper published that monoliths are better than microservices, but it's a circle. So you will build microservices in 5 years again. So our new parameter security, when we go back to the first slide, is identity. Identity is basically applications need to authorize against each other. We need to have a granular row access model inside of our clusters so that we use RBAC and stuff like this. We need our identity segmentation, that everything is basically, you only are allowed to do what you are allowed to do, because if you are admin, you still shouldn't be able to look into the deepest application layer, because that's not your job. Your job is to provide a platform. So there's also like, how do I secure the level of where I could go in? So we have tools for this, and because it's a container conference, we mainly talk about the tools that we have there. It's Kubernetes and containers. And we all know Kubernetes is a complete secure system, and nothing can go in there, and everything is automatically safe. Yeah, not. So what we need to do is we basically need to check for, hey, I want to have also my containers, as we said, because containers are a security risk. We need to have tools in place, ideally in our pipeline that we have as infrastructure as code, because we use immutable infrastructure that takes care of anything that is happening inside of our cluster. So we need to say, I need a tool to find dependency issues. I need a tool that finds compliance issues. So the idea is, you can buy some of those tools, but as I like open source, because I also do stuff for open source, there are a couple of tools that you can use that are open source. So for example, you can use Clear and Trivy for container scanning. They will also basically say what vulnerabilities you have. You can put them in your Harbor. So when you have, for example, Harbor as your registry, it is automatically integrated in Harbor. You also have tools like Gripe that is vulnerability scanner and also basically gives you a list of software bill of materials, so that you can say, okay, what are our dependencies? Where do I need to look into those stuff so that I'm safe on a container level? Once the container level is done and everything is fine, we can basically move inside of our cluster. And inside of our cluster, we luckily also have a couple of tools that automatically enable different stuff for our environment. So, for example, Kubebench, which basically checks your cluster against sys. By the way, a vanilla Kubernetes cluster is not sys compliant, just as an information. And if you use a system or a Kubernetes provider that like OpenShift, Rancher, Kubernetes, all of those clusters will also not be compliant with sys, because usually they have their own sys with specifics that are specific for the environment. What is also interesting is, for example, Kubescape, also open, all of the tools are open source, is basically a left to right. This is a security tool, good that I can write. Which basically includes also linting. It has a runtime threat detection. It's basically like a suite that you can apply and run on a regular basis on your clusters, or you can run it inside of your cluster. We have Falco as a runtime security. And now I know you don't want to hear it. AI. You have K8s-GPT. K8s-GPT is a CNCF sandbox project. The only thing why I listed there, I built the Gemini integration. Is basically it takes the events of your clusters and throws it against an LLM. The good thing is, it does not need to be an external LLM. If you run an LLM locally, you can also utilize the local LLM, and then it will translate events or issues inside of your cluster into a human-readable language and also gives you a thing how to fix this. And what is also possible to run is Popeye. Popeye is for linting your clusters, and it detects misconfigurations inside of your cluster at runtime. That's pretty nice. Of course, we talked about all of the stuff, but the main thing, and honestly, I will not cover this because this is probably a talk for its own, is observability. That's the biggest chunk that you should implement, that you have a permanent observability inside of your whole infrastructure, from application layer to environment layer to the bare metal layer that lies below, that basically detects, that have a threat detection, that detects patterns when something goes wrong, and that everything is basically safe. And now we have a new name. We call it now DevSecOps because we added a new part in it. So we forced the security team inside of our DevOps team, so that the people need to talk to each other. That's the main point. So that we have, every time when our development cycle starts, it's like we start on the development side for dependency issues or scan for dependency issues. We make composition analysis. We do penetration tests against our application code. Then we deploy it in our cluster, and there we monitor it on a always reoccurring state, so that we have any issue coming up or detected inside of there. And then the cycle starts again. So basically what we do is we just add the teams together so that the different people talk to each other and work together in a concert. And I know that's hard, and I know it will take a long time to implement, but that's basically the only way how you can ensure that your your application or your environment will stay safe. So the main thing that I'm advertising here is collaboration. Have your teams not split up in security, dev, and whatever. Create teams that work together and have basically where all of the resources are placed together, so that you can basically create a team that can work in cohesion and sharing responsibilities for the system. And then we have new topics or new names, and those new names are just additions. That's just additions what comes to our environment, and that are just basically adding more people and more parts in our operation. And eventually we will get to Triceratops, because Triceratops will be the best thing that we will achieve. So currently we are only at DevSec MLOps, because ML is a thing now in security eventually, but Triceratops is our ultimate goal that we hopefully will reach. And with this, thanks.
All right, perfect. We actually have some time for questions, which is great. So one question from me. You know, first you say nobody and nothing should talk to each other, and now we should also collaborate because we do DevSecOps. What's the thing?
In the past, no one talked to each other.
Oh, now we all talk to each other.
Now we should.
All the time. Also the pizza delivery guy, we should talk to him too. Okay,
yeah, and
good.
basically have him in handcuffs, only not looking left and right in our office.
Okay, cool. Cool. That was a lot of tools that you shared. What is the minimum viable security posture?
This, what I showed?
Everything. Okay, cool. Let's see. Okay, we have one question. Tools alone won't save you. Someone also needs to fix whatever you find.
Yeah, but the good thing for this is there are tools for automatic, for example, for vulnerabilities and package updates, there are also tools. And yes, your application might break, but I rather have someone fix my software bill of materials or my dependencies than be the next company that leaks like 500,000 people, or when was the issue? A couple of weeks ago, where 70,000 personal data was leaked again because someone just did not do their job. So fix your shit.
Done. That's it. Main takeaway from the talk. All right. How do you combat alerting or CVE fatigue?
That's a real problem, especially because of the thing that we have with the that kernel.org now do this weird thingy thing. The good thing is there are commercial tools. I'm sorry, there are only commercial tools that basically you say, I work in this technical, or my company is in this field because CVEs and also issues affect different companies more based on where they are located. So, for example, they are more targeted at finance or they're more targeted at manufacturing. And basically there the idea is, if something is broken in a build process that I don't do, I don't care. And there are tools that basically tell you, okay, this CVE is interesting for me, where I should have a look into this, or the other thing I can just rely on the update. For example, there was the CVE that affected ContainerD, and the ContainerD update in Kubernetes took less than 24 hours until it was fixed, PR was merged, and it was moved into a patch release. So usually the open source projects are really fast in fixing those CVE issues, and it also takes some time that people are starting exploiting those issues.
Very cool. This one is maybe a little bit related. How do you cope with critical vulnerabilities in latest base images? Do you want to talk a little bit more to that?
Yeah, that's what I just said. So, for example, the same issue, Flatcar had the issue in for another 2 weeks. And because we have all of the other security emplacements around us, if we have one CVE in the latest base image that could potentially affect us, we still have all of the other security environments that we build around it with microsegmentation and stuff like this, that if the chance that someone is exploiting us at this very moment, the blast radius will be very small. So that because of the combination of all of the layers of security that we build, it might not be as critical, so we can wait for the update.
All right, perfect. Let's do one more. Tool suggestions, always great. Would you recommend using something like OpenZT, or how do I even pronounce that one?
I must admit I'm not familiar with both of them.
Okay.
So if it works for you, it works for you. I just would rely on tools that I like open source tools more than commercial tools, because the blast rate or the radius where you get input is way bigger than if it's only company input.
That is fair enough. We're ready to take a break. I just want to say I'm kind of disappointed that you didn't mention your sheep when you were talking about pets versus cattle, because farmer, you could have done a great analogy there. Thank you so much for your talk. Let's do one more round of applause and then we go for a break.
Thank you.